Welcome to the Stormsurf video surf forecast for the week starting Sunday, April 19th. Looking at significant wave heights for the North Pacific Ocean, we see not a whole lot going on. Remnants of a gale working its way up into Alaska, not producing any seas of interest. Oh, maybe one little patch of 17-foot seas, but nothing really. Local north winds, the pressure gradient, typical off of Cape Mendocino, generating some seas pushing down the California coast, and otherwise just not a whole lot going on. Let's dive into the details. First up, jet stream level winds. These winds up about 30,000 feet help support the formation of storms and gales, and when those storms do form, help direct their track. Right now, we have a split jet stream pushing off of Asia. Not good to support storm formation. High pressure typically develops between the two split flows. Here's the southern branch working its way towards, I'd say the Gulf of Alaska. The northern branch split, falling through the Bering Sea, merging. They come together here in the Gulf, forming a bit of a trough. This trough here helps promote counterclockwise circulation, and it is counterclockwise circulation that is what makes low pressure in the northern hemisphere. So a little bit of support for low pressure right here, but then the jet stream splits very massively again, supports high pressure over the U.S. West Coast, and therefore no real support for storm development indicated. As we roll this into motion, the little trough here continues to work its way into the Gulf, but just not a whole lot of winds feeding it. Things try to organize a little bit come Tuesday. Now, this is a little bit of an interesting scenario. Watch this. This trough kind of falls down the U.S. West Coast, maybe promoting some low pressure, but not much. I mean, notice here, the wind's going to the north. So here's your trough, very steep indeed, pinched off, not doing a whole lot. And then back to the west, strong winds, basically pushing, not particularly strong, but for this time of year, 150 knot winds, just not organized. Here's another sort of a pinched off trough, but just not doing a whole lot. Then we get into Thursday here, and tries to organize a little bit more, but still no real clear defined troughs. Here we go, a little bit of a trough trying to organize here in the northern Gulf of Alaska on Friday. And then into Saturday, it actually starts looking somewhat better, and even more so into Sunday. And if the models were correct, this almost looks like a legitimate trough. Rather late in the season, late April, but with 140 to 150 knot winds flowing through the trough, this would support low pressure in down at the ocean's surface and continuing into perhaps Monday. So a little bit of hope there a week out. Next, we'll take a look down at the surface, and it is at the surface where wind blowing on the ocean surface creates raw seas, and seas, as they radiate away from the fetch area, that is the wind that's producing those seas, turns into swell, and swell, of course, if it propagates towards our location or here, produce surf. Anyway, so let's put this into motion, see what's going on. Right now, not a whole lot of wind here, a little bit of wind here, but what you really want, I mean, these greens, that's 20 knot winds. We're looking for 30 knot or better. It is roughly 35 knot winds that generate 13-second period swell. Here we go, high pressure, pretty much locked off the coast. That dooms any support for low pressure development. See a little bit trying to go on here on Tuesday, but just not a whole lot happening. So we get a little fetch here on Tuesday. Most of that wind is pushing up towards Alaska. A little tiny corner here, 45 knot winds, aiming at the U.S. West Coast. And again, this 35 knot fetch here, again pushing up towards the Bering Sea. Here we go into Wednesday. Theoretically, 45 knot winds pushing through the northern Gulf. That actually looks somewhat promising. Also notice rather strong. We'll actually go back here and notice it's 35 knot winds developing off Cape Mendocino. That's good for large or rather solid wind swell, if one is to believe the models. Then here, as we get into the weekend, remember we saw a big trough starting to set up here in the Gulf of Alaska. Let's see if anything materializes from that. We see, here we go, 30 knot winds. That's probably 11 or 12 second period swell, but we want to see something stronger than that, and it doesn't look like we're going to get there. Maybe a little pocket of 35 knot winds aimed towards the U.S. West Coast, trades for the Hawaiian Islands, and otherwise, notice 1032 millibar high. Pretty much, this is the name of the game now. It's that time of the year. High pressure takes control, but still, a little bit of hope about a week out. Let's see what the wave models tell us. So here we are, down at the surface. That is, this is the wave model, and the wave model, just for note, is actually a model of a model. It takes winds from the GFS model and then uses that to project what the effect those winds will have on the ocean surface in terms of how long is the wind blowing, how hard is it blowing, in what direction is it blowing. Those are the components that determine how high the seas are that are generated from those winds or that fetch. Anyway, we put this into motion. Again, we saw a little bit of activity here in the northern Gulf, but not doing a whole lot, and that peters out. Another low tries to get organized here. Doesn't appear to be doing a whole lot by Wednesday. And then that fetch we saw, the 45-knot winds, so we get 28-foot, almost 30-foot seas in the northern Gulf. Relative to Northern California, though, here is the cutoff for the San Francisco Bay Area. Just barely there, probably about 317 degrees. Relative to Hawaii, next to nothing. All that fetch is perpendicular to the Great Circle paths into the islands. Relative to Southern California, for the most part, completely shadowed, though a little sideband energy could get in there. Anyway, that thing peters out into Thursday. Now we're into Friday. A little bit of low pressure here. Notice just south of the Aleutians. This might be good for a little bit for Hawaii on about the 334, 333 degree path. But again, for the most part, perpendicular to the Great Circle paths there, but just the fact that it's relatively close, some small swell, 13-second period swell could result. But remnants of that energy work their way into the Gulf and start building in that trough there. And here we go. Now, relative to Hawaii, nothing going on here. But 20-foot seas relative to Northern California on the 296 degree path, and relative to Southern California on about the 301 degree path. And let's see if it builds anymore. Whoops, last frame, 180 hours out. Totally unbelievable, but just for fun. 22-foot seas on the 292 degree path, and what is that? All of about maybe 800 miles out from California. Probably good for some raw, larger swell in the 13 to 14 second period if it were to happen. Big leap of faith, 180 hours out. And of course, given the time of the year, we cannot ignore the southern hemisphere any longer. Small gale developed Monday a week ago. Got up to 32-foot seas for just a nanosecond there. Relative to Hawaii, that's on about the 196 degree path up into Hawaii and aimed well to the north. Relative to California, we'll just do Southern California here. What's that, about the 218 degree path, but very small. It was sort of pushing north. It's not shadowed by Tahiti, but again, very little swell is expected to result for the U.S. West Coast. And that thing just sort of faded out, and we got ourselves through the week. And now we're moving into current time. Here we are, rolling out, just looking for anything. Nice little storm here south of southern Australia, but not really in the U.S. swell window. We can do it that way. There we go. Actually, it is, but the swell vectors are almost pointing more towards Antarctica than up towards the U.S. West Coast. But notice here, the angle is almost dead flat, and that is what, 42? Oh, we got up to, here you go, now you can see it really well. Notice, sort of pushing south, but still, what is that, 45-foot seas and a very, very long ways away. But still, probably good for background swell. Not shadowed either on about the 218, 220 degree track relative to Southern California and relative to Northern California. Really no difference when you're that far out. About the same angle. Anyway, that system sort of crashes and falls and then tries to reorganize. This is the part we're actually looking for. Is in this area, the models have been hinting that something might try to organize down in here almost a week out. We're not seeing it so much in this run, but here you go. Look at this. Again, 162 hours, 45-foot seas relative to Southern California on about the 200-degree track. Not really aimed well, but still, with seas that large, you would expect some sort of swell to develop. But again, this is the fantasy issue. But look at that. Starting to lift north. We're 180 hours out. Relative to Southern California, that's... oh, it's hard to see here. Probably about the 190-degree track. No shadow to worry about. Nothing for Hawaii from this one if it were to occur. Relative to Southern California, also in about the 189-degree track. Solid swell result. I'd be more interested in looking in Peru, Chile area, and even up into Central America. This is where most of this energy is going to be targeting. Still, something to watch. It looks like the southern hemi is starting to come online. And now we start looking long-term. El Nino, La Nina, the Madden-Julian Oscillation, Pacific Decadal Oscillation. First up, the Southern Oscillation Index. Difference in pressure between Darwin, Australia and Tahiti. Daily numbers. Currently, plus 5.90. The 30-day average, minus 6.41. It is long-running negative numbers that are the hallmark of El Nino, or at least the active phase of the Madden-Julian Oscillation. The active phase of the MJO during winter months helps support storm formation in the northern hemisphere. Not so tight a correlation in the southern hemisphere, which may be good. Anyway, the daily numbers suggest sort of a neutral to just a neutral pattern, basically. But the 30-day average still showing negative, minus 6.41, and the 90-day average, minus 7.06. It's been hovering around minus 6 to minus 8 since October. This is suggestive of El Nino, but not strongly so. In comparison, the 90-day running average back in the big 97 El Nino was down around minus 25. So we have quite a ways to go before anything like that starts materializing. Here's the graphical depiction of the 30-day SOI. As we see, 2013, numbers were high, basically La Nina sort of condition. Then in 2014, early, massive dip in the SOI, massive change in the weather pattern across the Pacific Ocean, but it still did not materialize in El Nino, at least nothing significant. The numbers rebounded a little bit, but then by about June or so, they started going negative, and here was that minus 8 we were talking about. Draw a line through that. That's kind of about where we've been. We've just gone through a positive spurt. Now the bottom has dropped out. We're about ready to start moving back positive again. The question is, where is it going from here? We don't know. But at least we're on the bottom side, the negative side of the line. This is where, if any kind of El Nino were going to happen, it would happen. And of course, El Nino supports storm development in both the northern hemisphere and the southern hemisphere. So we're all for that, at least if you're on the U.S. West Coast and Hawaii. Australia, different pattern entirely. Next up, looking for wind differences. Differences in wind speed and direction for what is normal for this time of year. Specifically, the Kelvin wave generation area, what we call this area here. You take a little box from about 140, actually about 135, couple degrees either side of the equator, put it out to about here. What we're looking for is these arrows doing exactly what they're doing, blowing from the west, or what they call westerly anomalies. It doesn't mean there's actual west wind on the ocean's surface, but what it does mean is that trades are relaxed, because typically trades blow out of the east. But when you see this, that means trades are relaxed. That means warm water that's in this area can start migrating to the east, and when it does, typically it does it in the form of a Kelvin wave, warm water flowing below the ocean surface across the width of the equator and then gurgling up off the Galapagos. That is the hallmark of El Nino, or at least one of the building blocks that helps push you towards that. We have had continued westerly winds this entire spring season. Started in the January timeframe, westerly anomalies, then full-on westerly winds blowing 25-knot west winds at one point in the Kelvin wave generation area. That has formed a significant Kelvin wave that is working its way towards the Galapagos Islands. We'll get more into that in a minute. Anyway, so that's there. Relative, here's Hawaii, here's the equator, sort of a neutral pattern the rest of the way across the Pacific. Here's kind of the good news here. A week from now, notice, westerly anomalies still, and if anything, building in aerial coverage, covering the entire Kelvin wave generation area, though mainly on the northern side rather than the southern side of the equator, but every little bit helps. We'll take it. This has just been part of this ongoing pattern. It's been almost a year now for some sort of consistent flow of westerly anomalies, and it doesn't appear to be abating. This is good news for the formation of El Nino. Anyway, moving off. So there's the date line here. Things lighten up, but still westerly anomalies coming across the date line. And then so here's Hawaii, even south of Hawaii, on into almost halfway to the Galapagos. So a week out, much the same pattern as what is going on now is expected to continue. This chart, same thing we looked at, reds, orange, yellows, are westerly anomalies. Blues are easterly anomalies. We want westerly anomalies, and right in this zone, this is the whole planet laid out, but basically from here to here is the Pacific Ocean. Here is some of the last bit of those stronger westerly anomalies that occurred in late March, but still, here we are going into April, westerly anomalies, and here is the nice part. Suggested end of April, building westerly anomalies again. We would like to see this very much. Next up, the outgoing long-wave radiation models. That is, this yellows and oranges suggest areas where there's fewer than normal clouds for this time of year, more sunlight reflection off the ocean's surface, suggestive of high pressure and easterly anomalies. Westerly anomalies would be the blues, and more cloud cover, the active phase of the MJO, this the inactive phase. The interesting part is, supposedly we're in the inactive phase, and still westerly anomalies are blowing. Typically, westerly anomalies are only associated with the active phase, but they continue on, which suggests that there is some pattern more than just the Baden-Julian oscillation that's influencing global weather, or at least weather in the West Pacific at this point in time. This model, the statistic model, suggests the inactive phase is to fade out, and the active phase, very weak as it may be, work its way into the West Pacific 15 days out. The dynamic model suggests the same thing starting out. Of course, the inactive phase, but it's to quickly fade. The active phase tries to build, but then another inactive phase builds in the Indian Ocean, working its way west. In short, the two models are diametrically opposed to one another, but the interesting part is both of them are suggesting a very weak pattern. If El Nino were developing, that's exactly what happens with the MJO. The MJO basically disappears or weakens, and it is not tracked or is not really noticeable in its normal form, but westerly anomalies just take over the West Pacific, and they just keep blowing, pumping warm water to the west, and that's what gives you the classic warm water pattern off the Galapagos. We'll get more into that in a second. And then finally, the upper level 40-day model. No one believes a model that goes 40 days out. But the interesting part about this model is it at least gives you, one, a sense of so in this case, the greens are the enhanced potential for precipitation, and you can see it tracking from west to east. This is the way this pattern goes on the equator. Very weak, though. And then starting about the 28th of this month, a inactive phase supposedly working its way across the Pacific Ocean, and then perhaps the beginning of another active phase towards the end of May. But the interesting part here is all this is very weak. If we were moving into a El Nino-dominated pattern, that's exactly what you'd want to see, the fading of any of these cycles. So there's a little bit of hope in the models, all of them so far, that support that thesis. So where are we right now in terms of heating of the ocean? Where's the heat balance at? Right now, you see warm water developing off of Peru, Chile, the Galapagos, and of course, all along the U.S. West Coast and across the equator. It is El Nino's main signal is warm water buildup in this area, forming sort of a peak sticking out like that. We'll get into it in a minute. This is the result of previous west, and notice the warm water here. You get west winds blowing over this patch of warm water. It takes the warm water, pushes it to depth. It travels in like a bubble the whole way under the equator, hits the Galapagos Islands, this area, starts gurgling up, then gets caught by the trades and starts working its way to the west. Right now, we have a weak warm water signal, actually warmer than anything last year at this time. So just to compare, here we are this year, here we are a year ago. Notice cool water off the Peru and Chile. A little bit of warm water trying to get going here. This is the beginnings of what was called the Modoki El Nino, but just we'll go back and forth. Also notice, there was warm water. Here is the warm water pushing its way towards the U.S. West Coast. Pockets of cool water here in April. Look where we are now a year later. Much warmer. No pockets of cool water, just solid, lots of heat buildup. I mean, we'll just go back and forth and look at it, and you can just see marked difference between the two. Clearly, a warmer regime is in play right now. Anyway, This cool patch here, that was the other thing. This was a big concern last year. Notice how large it was, what a large expanse of area it covered. That would support high pressure at the surface. That has retreated some too. The smaller the cool patch, the less likely to support high pressure, the more likely to support El Nino. That's not to say that it is developing, but things definitely are looking better. And another way to look at it, this from actual buoys down at the ocean surface. The other was satellite-based data. Here's actual winds. You can see the trades blowing all along the Galapagos, but notice the trades basically dissipate over here in the Kelvin wave generation area, and you actually see some hints of actual real west winds. Not much, but this is actual winds, actual water temperature. Here's the anomalies. The westerly anomalies we were showing you before. Also notice 1 degree above normal temperatures the whole way across the equator, the whole way beyond the date line. That's warmer than we've seen in a while. But the surface is the tail of the dog. The nose is what's going on subsurface, okay? This is the West Pacific, this is the East Pacific, this is depth in meters. And here's actual water temperatures, not so much interesting. It is the anomalies, differences from normal. And here you clearly see the pattern of much warmer, 5 degree above normal water temperature. And where is that at? That's the core is down about 140, 135 west. So that's still a ways out in the Pacific Ocean. Some of that is already reaching the Galapagos Islands and Ecuador, and that is what's causing the warming there. The first little hints of this warm water working its way in. The core is out here still probably a month to 6 weeks from fully working its way in. So the expectation is water temperatures will get much warmer in the area of the Galapagos in the coming 6 to 8 weeks, let's say. The key is, after this all works its way in, what's behind it? Well, we do see that there's light westerly anomalies. This happened last year, and we'll get into that in a minute, where westerly anomalies continued, but they were very weak, not real supportive of a second large Kelvin wave, and so we never got much of an El Nino. The belief is, or the hope is, that we need another solid westerly wind event, probably in the May-ish time frame, to really set up a second Kelvin wave. The typical pattern is you get a Kelvin wave, then you get a pack of cold water coming behind it, which sort of looks like what this is trying to do here. And so this is the downwelling Kelvin wave phase. Then you get the upwelling Kelvin wave phase, cooler water, and then another Kelvin wave downwelling phase, and sort of does these cycles. In El Nino, it tends to be just a continuous heat pump without the breaks between. And during La Nina years, you get no Kelvin waves at all, or very few or far between, and very weak. So the hope is warm water in the west is going to start a giant slosh to the east to set up El Nino and then set us up for the winter of 2015-2016. But that is only wishful thinking at this point in time. Another modeled view of the current Kelvin wave. This one, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 6 degree anomalies suggested in this view. So we'll see. Anywhere from 5 to 6 degrees, it's a significant Kelvin wave. Make no doubt about it. Historic Kelvin wave, equivalent to what happened at the start of the 97-98 El Nino. But this very same thing happened last year, and then there was no follow-up, no significant Kelvin waves behind it, and that resulted in not a whole lot of warming and no big El Nino for the winter. In fact, you can see that here. This is the West Pacific. This is the East Pacific. This is upper ocean heat anomalies. That is differences from normal, the upper 300 meters of the ocean. This is in the April time frame of 2014, the big Kelvin wave that worked its way into the Galapagos Islands. Then the upwelling phase of the Kelvin wave, cool water. And then the whole through the summer, we had Kelvin waves, 2 of them, but very weak, not a whole lot going on. And once this cool water worked its way in to the Galapagos, these just weren't hot enough to get water temperatures back. And then yet another cool pocket after that. Now here we are in the current Kelvin wave, looking every bit as strong, if not stronger, than last year's Kelvin wave. But also notice here is cool water again setting up off way to the west. We'll see whether that really is going to migrate in or whether it's just going to get bottled off here, because the Kelvin wave generation area starts here. You get westerly anomalies blowing, but the suspicion is maybe this will moderate things long term. We'll see. And finally, the forecast for the Nino 3.4 region from the CFS version 2 model. Here we go. Currently about 1 degree anomalies, which is what all the charts support here in April. The forecast is only upwards from here. By July, we're forecast to be at 2 degrees above normal. That would be a significant El Nino, pushing to 2.5 degrees or even slightly above that by the November time frame. We find this hard to believe, but it is a nice tease. The interesting part is this model did the same thing last year at this time when that first big Kelvin wave started working its way into the East Pacific. This Kelvin wave is stronger. The model is responding stronger. We'll see what happens. So one quick thing to look for. Here we are, current sea surface temperature anomalies in the April time frame. We're going to go back to 1997 and look and see how the big El Nino of 97 evolved. So, a little bit different view, but still the same data. Notice water temperatures actually cooler in April 19th, 1997 than what we have today. More continuous warm water, and notice the little pocket of warm water between the Galapagos and the mainland. Same sort of thing showing up here. Also notice cooler waters, but again that warm flow working its way into the U.S. West Coast from the West Pacific. Also very present, even more so this go around. By May 3rd of 97, notice an apparent Kelvin wave starting to hit the Galapagos area. Warm water building and trades picking it up, pushing it off to the west. Looking almost about where we are right now. So we're about, maybe a week and a half, 2 weeks ahead of where we were in 97. By mid-May, more warming, obvious Kelvin wave impacting the Peru area. Building in late May, getting very pronounced by June 10th. Notice the extent of the warming here. Very deep, strong Kelvin wave. A lot of warm water building up. And by the end of the month, the end of June, significant warming in this area. This in and of itself would be a full-on El Nino, and this was just the end of June. Mid-July, the end of July. Mid-August, the end of August. Mid-September, the end of September. Significant warming still. Mid-October, the end of October. Mid-November, Thanksgiving time frame. Mid-December. Now notice, it already looks like things are starting to cool off. Little areas of less warmth right here along Central America, down in here. A more diffuse pattern appearing all over the Galapagos. And finally, the end of December, the peak of El Nino, the largest ever. So as you can see, here's the current chart. We have a long ways to go to get anything that would be considered a historic El Nino. But the point being that once this Kelvin wave hits and water temperatures start warming here, if you want to try to compare this one to the 97 El Nino, there can be no backtracking. The precedent is set. There must be continued warming in this area the whole way to December. That's a rather tall order to fill, and we suspect that will probably not happen. The signs of it will be obvious by about the late June time frame. The big Kelvin wave that's getting ready to hit will have done its thing by the end of June, if you see water temperatures starting to fall, if there's signs of an upwelling Kelvin wave coming behind it, then this is not going to be a significant El Nino event. It still might be solid, but it just won't be the way the charts are predicting, some epic 2.5 degree anomaly El Nino. So, something to look forward to. We're getting close to coming out of the spring unpredictability barrier. About another 6 weeks, we got a good Kelvin wave in flight. So that's it for this week. Right now, we have a rather lackadaisical pattern for the North Pacific Ocean. Perhaps some activity out of the Gulf, probably accompanied by north winds. It is the spring. The southern hemi appears to be trying to come online. The charts are teasing, but all the good stuff is more than a week out. There is a small little swell working its way towards Hawaii and possibly the U.S. West Coast. And then beyond that, there is the El Nino that we're watching to see whether it will develop or whether it will flub out like it did last year and just be another in a continue of the on-running Madoki El Nino style. Too early to know, but we do have a data checkpoint. By about the mid-June timeframe, we'll know where we stand one way or the other. So that's it for this week. We'll do this again next week, same time, same channel. In the meantime, go get some surf, have some fun. We'll see you next week. Thanks.